Hello, boys and girls, and we have a quick review of section 5.1 for trigonometry tonight. First of all, we're going to draw an angle in standard position. We're going to convert to radians, and we are going to determine a positive coterminal angle. So if we start with 510, this is in terms of degrees. We want to change to radians. So the unit multiplier that we will use to change to radians is pi radians over 180 degrees. This is our unit multiplier, and obviously we can use the reciprocal of it to go from radians to degrees. We're going to cancel the degrees. We're also going to cancel the zeros. Now we've got 51 over 18. 51 and 18 are both divisible by 3. 51 divided by 3 is 17, and 18 divided by 3 is 6. So 510 degrees is 17 pi radians over 6, or 17 pi over 6 radians. So we're going to put this in standard position. Remember, standard position always starts on the positive side of the x-axis, so that's our initial side. And then we're going to rotate. Now 510 degrees is obviously all the way around one time plus more. I'm going to count it in terms of units of pi over 6. Remember, pi over 6 is equal to 30 degrees. So there are 1, 2, 3 sixths in this first quadrant, because 3 times 30 is 90. So if we go around once, that is 12 sixths. If we went around twice, it would be 24 sixths. So let's go around once. Remember, that's 12 sixths, because 12 over 6 is equal to 2. And then 13, 14, 15, 16, and 17. So 17 pi over 6 is about right there. So 17 pi over 6, we can label that. That is 17 pi over 6 radians, which is equal to 510 degrees. And what would our coterminal angle be? Well, if we went 1, 2, 3, 4, 5, 6, then we could say that 5 pi over 6 is a coterminal angle, which is, of course, what we would get if we said 17 pi over 6 minus 12 pi over 6. So that's where how we can easily find that positive coterminal angle. We could keep going and even find a negative coterminal angle by simply subtracting another 12 pi over 6. So 17 pi over 6 minus 12 pi over 6 minus another 12 pi over 6 would be negative 7 pi over 6. So positive coterminal angle, like I asked, and a negative coterminal angle as well. Coterminal, remember that means they stop at the same point on the coordinate plane. Next, what is the length of the arc shown in orange if the area of the sector is 44 pi square meters? So this gives us the opportunity to work backwards from the given area. And remember, this is the area of this sector. And a sector is simply a fraction of the circle. We're talking about a central angle of 110 degrees. So 110 out of 360 times pi r squared equals 44 pi. So we need to go backwards because we need to know the radius of this circle. So this is our equation, and let's start simplifying. So first thing, let's cancel the zeros. So now we've got 11 over 36 times pi times r squared equals 44 pi. Let's also get rid of the pi from both sides. So goodbye, goodbye. So now we've got 11 over 36 r squared equals 44. Let's keep going, and let's multiply both sides by the reciprocal of 11 over 36, which will be 36 over 11. And from there, we are going to have the 11 cancel with the 44 4 times, and of course all this cancels, and we find that r squared equals 4 times 36. You can multiply it if you like, but it's not necessary because we are about to solve for r by taking the square root of both sides. And normally we would say plus or minus, but no need here because we're talking about the radius of a circle, so it's only the positive. The square root of 4 is 2. The square root of 36 is 6. 2 times 6 is 12. Our radius is 12. So, since our radius is 12, can we now find the length of the arc? Yes. We'll use the arc length formula. So if the sector is a fraction of the area, the arc length is simply a fraction of the circumference. So circumference is 2 times pi times r. And we now know that our r is 12. So 110 out of 360 times 2 times pi times 12. So let's do some simplification here. First of all, the zeros. And now we've got, first of all, this is not an equation, so we're not dividing anything away here. This is straight multiplication all the way across. So we've got 11 over 36 times 2 over 1 times pi times 12. Let's cancel the 12 with the 36 3 times. And what do we have left? We have 11 times 2 times pi, which is 22 pi all over 3. This is the arc length. Arc length. Remember, that would be in just meters, as the radius would also be in meters, since the area was given in meters squared. We can totally do all of that without a calculator. Now this last one, a calculator is going to be handy because we are going to find the angular velocity of a bike's tire if it has a radius of 14 inches and the bike is moving at 12 miles per hour. So what do we know? Well, we know that we have a radius of 14. So let's visualize that. The radius is 14, which means our circumference is 28 pi inches. Next, we also know that the bike is moving at 12 miles per hour. That's what I'm going to start with, this given rate. The given rate is the bike's linear velocity. We're trying to get the angular velocity. And we can get an angular velocity in revolutions per minute or radians per minute, whatever. And I did not ask that in the question, so how about let's amend the problem and say I want to know the number of radians per second. So let's go all the way to radians per second. That is going to be the angular velocity. The angular velocity is simply how fast the tire is revolving. That's the difference between angular velocity and linear velocity. So we're starting with 12 miles per hour, and we're going to have all our unit multipliers lined up across the page, watching them cancel. So 12 miles per hour. Let's dump the hours first because we're trying to get all the way to seconds. So 1 hour is equal to 3,600 seconds. So we have dumped our hours and we've got miles over seconds. We want radians per second. Now let's go from miles to inches since our circumference is given in inches. So 1 mile is equal to 5,280 feet. And that allows us to cancel our miles. Think about what we want to cancel because that's what we want in our unit multipliers. Then 1 foot is equal to 12 inches. Feet cancel. Now we've got inches, and now we need to relate inches per second, which is a linear velocity. We're trying to change it over to an angular velocity. This is where the circumference comes in. 1 revolution of the tire is equal to the circumference of the tire, which is 28 pi inches. So inches cancel. We've got revolutions over second. We want to go one step further and get all the way to radians. 1 revolution is equal to 2 pi radians. Now revolutions cancel. And the only remaining units we have are radians and seconds, which is exactly what we want. So now we are going to multiply straight across, and I just have my phone here, so that's what I'm going to be using. So that's going to be 12 times 5,280 times 12 times, and I'm going to go ahead and cancel those pi's, so that's one less thing I've got to put in my calculations. So 12 times 5,080 times 12 times 2. So my numerator is going to be 1,520,640 over, and then to the denominator, 3,600 times 28. 3,600 times 28. Denominator is 100,800. So this is what I've now got to divide. So here we go. 1,520,640 divided by 100,800. And that gives me my answer, which is 15.1 radians every second. That's the angular velocity of the bike. Remember, the bike was moving at 12 miles per hour. That was the linear velocity. And we just converted that through dimensional analysis to the angular velocity. The angular velocity is the rate at which the rotation is changing. In this case, it's changing 15.1 radians every second.